Hello, this is a continuation of the video on the dome home or the dome structure that I am designing at the moment. And just this is again just to share uh, again the design concepts and some of the design ideas that are behind the drawing, the actual design. I am going to be sharing this design with you, the viewer, and perhaps many other people that would like to take a look at this because I believe it has a lot of uh, unique and original uh, building characteristics, design concepts, and design approaches, and also building and construction methods that are um, basically I've had to develop as I go here and move forward with the design because I have to and I have kept in mind uh, how to go about building this thing, how to go about the different techniques that will be used, methods, materials during the construction. You have to keep that in mind as a designer, how the thing you are designing will be constructed, put together, assembled, built. Again, this is a BIM or BIM design, building information modeling design, and there's a lot of thoughts behind it, information, if you will, put behind all of the uh, aspects of this design. So this is where I wanted to begin from the uh, last where I left off at last video where I left off at the last video. This is the what I call the base. Some of you may call it the foundation. Some of you may call it something else. But this is pretty much where it starts on the ground. Uh, this is a concrete block array going around what you can tell is a circle, more or less a symmetrical circle or circumference, whatever the word you may want to use. This is what that is. These are 8-inch by 4-inch standard cinder blocks, or what they call concrete blocks here, and they are arrayed as you can see. Um, and of course mortared together. They are very much uh, stuck to each other by way of mortar or concrete mix. And this I believe to be a very stable foundation, strong and coherent foundation. As you can see, the in this view, I will change the view from the top, and I will make it a parallel projection, take away the perspective aspect or view of it. So it's basically seen as straight lines, as you would see it in a drawing, 2D drawing, two-dimensional. And as you can see, these blocks are arrayed in a way from the center that they converge from the center. As you can see, there's very little separation. However, there is some separation on the inside and a lot larger separation on the outside for each block. That will give it the circular array uh, as perfect as possible. And of course, in between those narrow voids is where the mortar would go, the cement mix to bond these blocks together. And not only will these blocks be bonded together with mortar, but they will be bonded with steel, uh, either rebar, steel wire, or steel belts, whatever your choice may be, or something else that's long lasting and corrosion proof. Before I move on to another aspect or area, I would like to discuss these. I call them concrete block bases, and I will bring the other view, which is the southwest view again. And these blocks are basically the same blocks arrayed in another fashion. 4x8s, excuse me, 4x4s, meaning that there's 4 on top, 4 on the bottom. And of course, they are bonded with mortar. I believe I have shown the mortar on these particular blocks. Unlike here, I don't show it, but maybe I will somehow show it on the drawing, include that. And I don't have a count for how many blocks these are. I will get a count here when I begin doing my inventory of materials needed, but it's quite a bit of them. Don't want to really guess or estimate how many at this moment. But the pillars, excuse me, the block bases here, I will probably be modifying this one right here. But these block bases, of course, there are about let me see, I can count them right now. 1, 2, 3, 4, 5, about 16 of them. There are about 16 of these blocks, not the blocks but the actual bases, which again are 8 of them, excuse me, 8 blocks, 4 on top, 4 on bottom. And those will serve as the base or support for the floor frame of the structure, which I'll show you here shortly. These again are as I mentioned earlier, the columns or pillars. I call them pillars because they are what will provide the structural support, structural integrity, strength, and durability of the inside framing of the structure. Not necessarily the outside, but they will also support the outside skeleton, what I call the skeleton. I have, very originally or uniquely named a lot of these aspects or parts of this design because not only is it a unusual and unconventional design and construction, but also I have to differentiate between the inside frame and the outside frame in the design and also in the vocabulary used, because the outside frame is able to self stand or stand alone. It's a standalone structure that needs no inside frame for its support, for its integrity, and its um, resilience, structural resilience. It's self-standing, it's standalone, as they call it. The outside, of course, we'll name it as a skeleton, and the inside, I will call it steel frame. The outside is going to have the curved, as you will see, structures, members, and I will discuss that later. And the inside is going to have the more conventional straight, vertical, and horizontal members, including these 11 pillars. I believe there are 11 in fact. Let me make sure that before I'll leave you with that. And counting 4 and 4 is 8, 10. I'm counting 10 plus a center. That's 11. So 11 pillars. And these are going to be more likely than not steel structures, steel members, more like steel columns. There could be I-beams, I-beam columns. There could be square, hollow steel, or whatever variation would be, like U, maybe like a U shape, steel beam or column. I mean, whatever works for the design, of course, whatever works so it can securely attach the other members. This can also be wood. It is designed to be flexible as far as what materials are used. I originally designed this whole structure to be made out of entirely of wood and concrete, wood materials and concrete materials, and very little else, perhaps a few steel components like rebar and steel belts or steel wire, and perhaps some steel bolts, carriage bolts. But it is very much designed to be built out of mainly wood materials and concrete, and I will show you that as I go along. So, to discuss the next topic, it's these large concrete bases for the pillars, the columns. 11 of them, of course. I believe there are only 10 of these bases, concrete bases, because of course, this one has a double, two of those pillars, columns, encased in one concrete base, what I call foot. I call these feet as a group, foot as individual members, objects, and some of them vary in size. Of course, this is the largest of them all, perhaps the only one that's large enough to go all the way in line or at the same height of these concrete block bases, and deep down into the ground. And I'll show you, you can see more or less where the ground level would be as you look at where those rays go. That's the ground level, so you can more or less estimate just by looking at this where the ground level is. I can do you a favor and turn on the ground, which has been also designed. And this view here will show you where the ground level would be. Of course, you can see that middle foot, concrete foot, is in line with these, providing support for the floor frame. Unlike these concrete feet or pads or bases, which are only a few inches into the ground, they pretty much provide footing on packed ground for the floor structure. Not necessarily, they don't necessarily provide the side forces support that these would have to provide. Those provide support for side forces, side pressure, such as me pushing on that column from the side. That foot, concrete foot, will provide a counterbalance, counterweights, along with the vertical counter force and horizontal counter force to basically minimize the side to side, front to back movements of these very tall columns, some of which the tallest ones are over 26, 27 feet high, quite high. Again, this is a two-level, two-story, two-deck structure, and approximately at the where that line is where the first level, first deck, the top of the first deck is. That line pretty much divides the first deck and the second deck of the structure. But these are whole members. These are entire, complete members, not to be cut or broken or in any way weakened structurally. So moving on, these right here, these bolt looking things are, that's pretty much what they are, bolts, carriage bolts. And I will change the view so you can see from the bottom. Let's turn off the earth or the ground. And I'm looking at the drawing from the bottom, as if I was underground, to give you a better look of those bolts. These again are carriage bolts. I believe they are about 14 inches or more high, probably about 15 or 16 maybe. I would have to get the true measurement of that, and I believe I can with this. So I will try to measure distance from the center of that to the center of this, and that gives me a distance of 1 foot 7 inches. That's 19 inches. Which I believe is not accurate. It may be a lot less than that, but let's go with that. Let's go with 19 inches because this right here, from this distance here in the block, is 8 inches, and we're going up, yes, another 12 inches. So it's yeah, it is about 19 inches or so. So let's call them 19-inch carriage bolts. Again, these are an array, in array. As you can see, the blocks are bored first, and then the bolt is inserted. This again is a threaded bolt, of course, and it will take washers, lock nuts, and nuts or nuts for the bolt. And changing the view again, you have to excuse this. I'm using a computer that is not fully equipped to handle this kind of 3D model. So this is a view of the bolt. Again, this is a 6-inch tall piece of or wooden belt. It could be wood or another material that will take that shape, that circular circumference shape. So this is from top to bottom 12 inches in total. So 12 plus 8 inches going down. No, excuse me, that's not 8 inches for that block. That is the small side. So that is 4. So 12 plus 4 is about 16 inches. And give or take a couple of inches, you will give or take about half an inch, you will have a 16.5-inch bolt at least. And of course it's going to be secured with a nut and a washer, at least perhaps a lock washer as well. And it's designed to be about half an inch in diameter, the bolt itself, and there are 24 of these that go around the perimeter, equally spaced as much as possible. Of course, there will be some areas where you may have to deviate from the symmetric spacing because of other structures in the way or whatever the case may be. And I think there are maybe just 1 or 2 places where the spacing may have to change, as I will show you in the design. And the purpose of that, if you don't know, is because the purpose of the bolt array is to maintain the shape of the dome. A dome is a very strong structure. However, it has one weakness, and it's that on the bottom it needs to be anchored, because it will tend to spread on the bottom when downward forces are applied to it, such as wind, snow, rain, or just plain old always working gravity. Gravity works downward towards the center of the planets, so the natural reaction of a dome is to spread out, and these bolts will prevent that. The bolt array will prevent that, working together with this belt, which is designed to be made from wood, but not necessarily so. It could be made with other materials such as composites, such as steel or other alloys, metals, but something durable and strong. Before I move on, also I'd like to discuss these holes. Um, they're about 24 inches by 24 inches wide, and they just provide access to this inner area for maintenance, repairs, for additions, uh, modifications, whatever. Eventually, there will be a need to access the bottom area of the structure, which is basically a crawl space, more like the crawl space in a mobile home or pre-manufactured home here in the Americas. So that is the idea behind those uh, entrances, windows, or holes, whatever you want to call them. So I believe that is all for the base of the structure. Again, it is made with concretes. I will probably include a way to uh, include the steel belting required for this structure. Of course, this is not as stable as I would like it to be unless it is steel reinforced or reinforced with some sort of material or members that hold all these blocks together even more than the bond provided by the mortar. Of course, the bond provided by the mortar is not optimal as far as keeping the array together over long periods. However, it is, I believe, stable enough to last about a generation, I think, without steel belting or steel reinforcement. But I will probably add that and perhaps even change this design to be cast concrete, or basically a cast concrete wall instead of an array. Another thing I wanted to mention is that this structure is designed to be built by as small of a crew, the smallest crew possible, perhaps even one or two people. Of course, the bigger the crew, the more efficiently built it will be, with, of course, a top number or a number of people being optimal. Perhaps a crew of 4 to 6 people would be more likely optimal, but it was designed with the concept of being built by even one person. Of course, using machinery, technology, cranes, equipment, construction vehicles, uh, and an ample use of scaffolding. Scaffolding will be needed, especially to construct the outer structure, and the inside structure, of course, is a two-level structure, and even without scaffolding, it may be able to be built if you build the inside first, and that is probably a good approach, to build the inside of the structure first, and that will minimize the amount of scaffolding needed to build the outer skeleton. So I will go with that first. I will go with that approach. That may change depending on what I find over time, and and depending on what I find during my construction methods research. But I think doing the inside out building approach, bottom to top, I believe to be a good starting point for right now. So I will turn on a few more items and show you here shortly uh, what the inside structures are going to begin looking like. Okay, so this is right here the floor frame. Just turned on the layer for the floor frame again using the DWG True Viewer. This design again was done in AutoCAD completely, and as you can see, the floor frame is designed to be built out of wood lumber members. These are 6x2s. Of course, that's not the exact dimension of those. I believe it to be about 5.5 by 1.5 inches. And as you can see, most of them are to be resting, or most junctions, excuse me, most junctions here, crossed junctions, are to be resting on those concrete bases, including the center one. And I may want to add maybe one more here, perhaps two more in this area, but I think one more right here would be sufficient for support. But I believe it to be sufficiently sturdy as it is, especially if you use other materials other than wood or lumber. You can use, of course, steel. You can use steel trusses, I trusses, they're shaped as an I or T trusses. It could be another alloy that's a bit more sturdy than wood, but I believe wood would be quite appropriate for this design, for this structure. Of course, that would need bracing, metal alloy bracing. There would be an attachment to that pillar or column right there by via braces or straight bolts, bolting through it, of course boring it, drilling through it, and then bolting them. Those two columns appear that they could be secured to the floor for further support, not only for the floor but also for the columns themselves. If they're attached to other members that further stabilize it vertically, then that is always better than not. And a view from the other side will show some of those attachment points a bit better. So right here, attachment right there. Of course, that looks like it's going right through it, but you don't want to make that hole on that pillar or column. You want to break this member and brace it, attach it to the complete pillar or column. Attachment points right here and here, center, of course. and wherever they meet there would be attachments, secured attachment points via bolts. I would try to avoid using screws for those attachments, especially since we're talking about these pillars. And I may show those here in further versions of this drawing. The floor frame is going to also be resting on these concrete blocks arrayed in a circle, of course. As you can see here, this right here I believe is missing a piece. It should extend all the way out. That may be an error in the drawing, which needs fixed. But as you can see, these right here, these pieces extend well into the concrete blocks for support. And again, those could be metal members or wood, lumber, or even other exotic materials such as composite, which may become more available in the future. So I will turn on a few more items. Okay, now that you've seen the floor frame, I am now showing you the floor paneling. These are nothing but 4 foot by 8 foot plywood panels, sheets of plywood, 4 foot by 8 foot, and they're pretty much intact on the middle, about on the 12 middle ones, and then on the ones on the perimeter, of course, they're the same sheets or planks of plywood cut from any circle from the center, as shown in the construction drawings or documents. I will give you the circumference, the radius, the diameter of that cut, but it's relatively simple. And of course, those are to be attached to the frame via screws, adequately sized deck screws. This is a bottom view from underground as you see it. And those are spaced so that you can attach each board to each one of these members very easily, efficiently, and conveniently. And simple enough for construction. Could be done by a very small crew of medium to even low skill. Of course, the higher the skill, the better. So moving on. Okay, moving on to the interior. This is pretty much the interior structure. I noticed a lot of pieces are missing somehow. They probably need to be, yeah, there's a problem here with the model itself. Is showing both floors, both decks, when it's supposed to be showing one. So I will show both decks at once. Since there's an issue there I have to address with the layers. Layers are nothing but different categories of items that are categorized by layer in the CAD software I used, which is AutoCAD. And you can assign different items, different structures, different objects, different lines, different aspects of the drawing to one layer, uh, to separate layers. That way you can turn them off and on and show different things without showing others. That makes it a lot easier, more convenient. So right now I'm showing both decks. This is the inside or inner structure of the dome structure, the home. Again, showing the pillars, which are shown here in red or dark orange. The columns are shown in lighter orange, each smaller column. These are designed to be, the smaller columns are designed to be about 2x4, the standard 2x4 here in the US, which is about 1.5 inch by 4 inches. Excuse me, 3.5 inches. 1.5 inch by 3.5 inch. And the bigger pillars, those deep red, dark red, or dark orange columns, are designed to be 6x6 standard, which is 5.5 by 5.5 inches. And that is the width, the cross section. Of course, the length varies as shown in the construction drawings. And the ones shown in green are the cross members, the support members, I call them, the cross bracing, to maintain integrity and stability. And as you can see, these are the structures for both floors. So I will pause right here because I want to show one floor. I don't want to get ahead of myself and show too much, and without going over a few of the things. So this is giving you an idea of how the inner structure is. Let me show you a view from the rear. Of course, there's a tree in the way. I would have to turn that off. That is a reason why things are put in layers, to be able to turn them off as needed. If I could just find it. Turn all those off. External references. So this is more or less a view from the north, which is the rear of the structure. As you can see, there's on the second level there's a bridge that goes from one side to the other. I believe it to be a very nice design detail there. As you can see, a head-on view. There's that bridge with the rails. Those are handrails for safety, of course, and structural integrity as well. And that is the center column there in the center, and this is the left side, right side, depending which way you're looking at the building. Of course, from the other end, from the south side, it would be the opposite. And one thing that is missing here that I can turn off momentarily is the floor frame for the second floor, which I'll just turn on here just for show. But again, I will address the issue there with the categorizing of the upper deck and lower deck layers, and I will come back and further detail or analyze the first deck in its entirety. So we'll turn on the second floor. I don't think that caught that. The second floor frame for the floor. And there it is. This frame right here. Very similar, if not identical, in design to the first floor. But of course, it's going to match the dimensions of the second deck. And I will show that in a perspective view from the bottom first. As you can see, that is the second floor frame in yellow, bright yellow. And another view from the top. Second floor frame in bright yellow. Of course, this is just a show of what the structure looks like. This is by no means a construction document as I'm showing it. Of course, there will be dimensions given. There will be details given as far as attachment points and many other details that are included in the construction drawings, again, which I will include here in this website that you're looking at this presentation on. Look for a link, whether it's in the description, comments section, whatever. So we'll leave it at that for right now. Thank you very much. We'll catch you in the next video. Goodbye.